Here it is, UH Quiz 10 rates. I'm going to read it and we're going to go through it slowly. And if you have questions, please ask me, guys. Please, please, please. It says, find the rate of change of area of a square with respect to the length z, the diagonal of the square. What is the rate when z equals 6? Okay, I love it because area of a square should have been x squared, right? So here's my square, and that would have been x, and that would have been x, and you would have said area equals x squared. But they don't want it in terms of x, they want it in terms of z. And they tell you that z is a diagonal. So here's the relationship between the x and the z. We're going to have to do Pythagorean theorem. So x squared plus x squared equals z squared. And then I see that I have two of them. So I'm going to go 2x squared equals z squared. But remember, area is x squared. So you want to get x squared by itself. Divide by 2. Divide by 2. So I'm going to say that x squared is equal to 1/2 z squared. This is what I'm going to use for area. So I'm going to say area equals 1/2 z squared. Have I lost anyone? Okay, then I'm going to say, I'm going to take the derivative of area with respect to z. So I'm going to go dA dz equals 1/2 times 2 is 1 z. dz dz, but you don't need that. And then it says, what is the area when z equals 6? What is the rate of change of the area when z equals 6? So dA dz when z equals 6 is just 6. So letter A. So this person did not get it right. Did all that make sense? Well, I felt like I was going to fall down right there. All that makes sense, guys? Okay, let's go to the next question. Oh, man. Okay, let's see what makes this question hard or what made this question tough. The area of a sector in a circle is given by the formula A equals 1/2 r squared theta. Okay, where r is the radius and theta is the central angle measured in radians. Find the rate of change of theta with respect to r. So they want d theta dr if a remains constant. So a is a constant. What is the rate when r equals 5? Okay, here's what you're going to do. You take a equals 1/2 r squared theta and solve for theta. Solve for theta. So I'm going to multiply by 2. Child, why are you doing that? To get rid of the half? Whatever you do to one, do to the other. So now I have 2a equals r squared theta. Have I confused anyone? Yeah, I was going to do it in one step, but I listened to you guys. So look, I'm doing what you guys told me to do. Do more steps. I'm going to divide by r squared. So right now I have theta equals 2a over r squared, but I want you to remember that a is a constant. Because a is a constant, I'm going to bring r squared up. So I'm going to write theta equals 2a r to the negative 2. And I'm cooking today. All right. What you're going to do now, I'm just going to take the derivative with respect to r. So I'm going to go d theta dr equals 2 times negative 2. Oh, what's 2 times negative 2, guys? Negative 4. A r to the negative 3. They're not going to have it written like that. So look for d theta dr equals negative 4a over r cubed. So negative 4a over r cubed, maybe. And it looks like it has to be letter C. Next, what do they say when r is 5? So let's see. D theta dr equals negative 4a over 5 cubed. Yeah, 5 cubed is 125. Negative 4a over 125. Letter C. Ask me, guys, how do we feel so far? We got it? Hernandez, you think we're good? Okay. All right. Here we go. The very first, it's not too shabby, this one. We are going to need calculators eventually, so let me get my calculator out. If you guys want to get a calculator out just in case. It says, what does it say? Okay, clear. All right. An object moves along a coordinate line. Its position at each time t greater than or equal to 0 is given by, and they give us this. Find the velocity when the initial time is 3, where that usually t naught means initial time. Usually. In physics it does. All right. You can, if you want, do product rule, if you want. What do you notice, though? Do you guys notice something? The difference of squares. So you can make life easier and do this. T squared times t squared, that's t to the fourth. 3t times 3t, that's going to be minus 9t squared. See? And now all you got to do is take a derivative. That's all. That's it. V of t equals 4t cubed minus 9 times 2 is 18, 18t. You're done. All you got to do now is plug in the 3. V of 3 equals 4 times 3 cubed minus 18 times 3. Let's see. 3 cubed, 27. 27 times 4. I'm just going to do the calculator. 4 times 3 cubed minus 18 times 3. 4 times 3 cubed minus, delete, minus 18 times 3. There it is, 54. Look for 54, and this person got it right. Yay. Are we feeling okay so far, guys? All right. Question number 4. Ooh, I love it. We haven't talked about this formally, but it's a good question. An object moves along the x-axis. Its position at each time t greater than 0 is given by, and they give you an equation. Determine the time intervals, if any, during which the object slows down. Okay. Before we tackle this problem, be honest with me. Do you know what we are looking for when something is slowing down? When the terms of velocity and acceleration? No? Okay. If velocity is positive, that means you're moving to the right. So velocity alone will not tell you if you're slowing down. You need acceleration also. So think about it. Velocity positive, acceleration positive. If velocity and acceleration are both positive, are you speeding up or slowing down? Speeding up, because the acceleration is in the force of your velocity. Does that make sense? So if velocity is positive and acceleration is negative, what's happening? Slowing down. Do you guys see that or no? Be honest. Okay. So that's what I'm looking for, where velocity and acceleration are opposite signs. So let's find my velocity. V of t equals, I'm just taking a derivative. Negative 1/4 times 4 is 1. So negative t cubed. Next, 27 over 2 times 2, that's going to be 27. So plus 27t. I'm going to equal this to 0 to get my critical numbers, guys. Equal this to 0. And look, I'm just going to factor out a negative t. And I'm going to have t squared minus 27. So let's see what I get. I get t equals 0, which is not a big deal. That's just where I'm there, right? And then let's solve this. T squared minus 27 equals 0. T squared equals 27. Okay, I know I'm going fast. I'll slow down. All I'm doing is finding zeros like you were when you were in algebra. Square root. 27 is 9 times 3. And the square root of 9 is 3. So 3 square root of 3. So here's my velocity graph. This is velocity. And I'm going to put a little hashtag or a little marker there. All you care about is positive or negative, guys. All you care about is positive or negative. If I plug in a 1, 1 squared minus 27 is negative. A 1 on the outside is negative. Negative times a negative is a positive. If I plug in a number bigger than 3 squared root of 3, Chav, I don't know what's bigger than 3 squared root of 3. Like 10. 3 times 3 is 9. But that's a square root of 3, right? So if you want to be safe, just go like 10. 10 squared is 100. 100 minus 27, that's positive. 10 on the outside is going to be negative. Negative times a positive is negative. So look, just focus on that for now. That's a plus and that's a minus. All right, now I'm going to find acceleration. I know, guys, it's a lot, but don't worry. It's not as bad as you think it is. The derivative of that, negative 3t squared plus 27. I'm going to equal that to 0 to see where I have a sign change. Negative 3t squared equals negative 27. Divide by negative 3. T squared equals 9. T equals 3. Square root, square root. It would be plus minus, but I don't care about the negative. All right, check it out. I'm going to write it down here like this. I don't want to use blue because you might get confused with that. I'm going to put the acceleration right here. This is my acceleration. The only number I get is 3. By the way, 3 is smaller than 3 squared root of 3. So I'm going to say 3 is like right here. I pick a number. Chop, what are you doing? I just care whether acceleration is positive or negative. I pick a number like 1. Negative 3 plus 27, positive. I'm going to put a plus symbol. To the right of 3, like 4. If I choose 4, 4 squared, 16. 16 times 3, 16, 32, 40, 48 minus 27. Negative 48 minus 27, negative. So negative 48 plus 27 is a negative, so minus. So where are the signs opposite? I'm going to choose green. Check it out. It happens right here between 3 and 3 squared root of 3. The velocity is positive from 0 all the way to 3 squared root of 3, and then goes to negative, but the acceleration is positive from 0 all the way to 3, and then at 3 it turns to negative. Do you guys see that? So opposite signs between 3 and 3 square root of 3. That's where the velocity and acceleration have opposite signs. Does that make sense to you guys? Yeah, stop me. Demon, tell me. Yeah, all I did was I just plugged in numbers, guys. I just had one critical number for velocity, and that's the only time I changed from positive to negative in velocity. And then for acceleration, I just had 1 as well, and that's the only time you change. So in this interval between those green lines, see how that says negative there? But in the velocity, it's still positive. And that's the only time that the change are opposite. Other than that, everywhere else you're speeding up. So slowing down in between those green markers, guys. I know, that one was tough. Oh, this person got it right. I didn't notice. All right. Let's see. Oh, yeah, this one you can do with kinematics, but this is one of the easier ones. An object is dropped and hits the ground 0.5 seconds later. From what height in feet was it dropped? Okay, so I'm just going to use the position equation. I'm going to say my position when I dropped it was 0. So that means whatever value I get is going to be negative. I'm going to take the absolute value. Does that make sense? So look, acceleration due to gravity, negative 32. I'm just going to keep going until I get my position equation. I'm saying that this is my initial position is 0. My initial velocity is 0 because it was dropped. Antiderivative, v of t, negative 32t. See? Plus c, but c is 0. So I don't have to worry about it. Antiderivative of that is my position, y of t, negative, I'm just add 1, divide by 2, negative 16t squared. Done. Done. You're done. Y of 0 is 0, remember? So I'm just going to plug in the 0.5 to see how much I went down. Y of 0.5 equals negative 16, parenthesis, 0.5 squared. So negative 16, parenthesis, 0.5 squared is 0.25. So that is negative 16 times 1/4, and I'll slow down. So if I count my initial position as 0 and then the floor where it hits, that's going to be negative 4. And what did I tell you? Take the absolute value of negative 4, because that's my position, right? Here's my position 0, that's position negative 4. So my distance traveled, 4. Do we have any questions on that, guys? Okay, here we go. Now we start getting into the fun ones. Try to route small on this one. Well, actually, the numbers look pretty, so it doesn't look like it's going to take too long. If it would have been fractions, we would have maybe just like the one we did yesterday. A falling stone is at a certain instant 350 feet above the ground. Okay, so I'm going to write y of t1, because I don't know the time, 350 feet above the ground. And 3 seconds later, it is only 14 feet above the ground. So y of t1 plus 3, 14 feet. From what height was it dropped? Okay, So this time, this initial height, I want to know that number. So I'm going to be taking the antiderivative. I'm going to say ground level is 0. Does that make sense to everyone? So ground level is 0. So I'm up here. That value, that's y equals 0, ground. I want this height. Want height. That's a picture. I tried to draw a picture. Okay. What am I going to do? Acceleration due to gravity, negative 32. Oh, it was dropped. It's going to make life easier too. V of 0 is 0 because it was dropped. It was dropped. Antiderivative, V of t equals negative 32t plus c, but c is 0. Are we okay so far? Another antiderivative, y of t equals negative 16t squared, add 1, divide by that number, plus c1. That's what I want. What I want. So here you go. We're going to do 2 equations. Equation 1, I'm going to go negative 16 parentheses t1 close it squared plus c1 equals 350. Equation 2, negative 16 parentheses t1 plus 3 close it squared plus c1 equals 14. I'm going to do algebra with equation 2, guys. I'm just expanding it. I'm going to go slow. Negative 16 parentheses t1 times t1 is t1 squared plus 3 times t1 is 3t1, but you're going to have 2 of them. So 6t1 plus 3 times 3 is 9 plus c1 equals 14. I'm going to distribute. Slow down. Negative 16t1 squared minus 16 times 6. Is that 90? 16. I'll just use a calculator. 16 times 6. 96. Minus 96t1. That's why I'm going to have it a little bit left over. 16 times 9. Help me out, guys. Help me out. 144. Minus 144 plus C1 equals 14. Are we okay so far? I'm going to move this minus 144 to the right. Negative 16t1 squared minus 96t1 plus C1 equals 144, 54, 54, 58. 158. All right, we're good. We are so good right now. We got 2 equations, 2 unknowns. I'm going to put them back to back. I'm just going to go equation 1, negative 16t1 squared plus c1 equals 350. Equation 2, negative 16t1 squared minus 96t1. I know there's not a 96t1 in there. That's going to be by itself. Plus c1 equals 158. I am going to subtract the bottom one. The 16t1 squares cancel out. The c1s cancel out. Chav, I thought we were looking for c1. Yes, we are. I'm going to have a positive 96t1 equals 350 minus 158. 350 minus 158. 192. Oh, that's a perfect number. 192. T1 equals 96. I want to say 2, but paranoid here. So 192 divided by 96. Yeah, 2. Yeah, it's going to be a pretty number because look at all those. So if T1 is 2, now we just plug it into whatever equation we want. Obviously, the green one, guys. Don't make life harder. So negative 16 parentheses 2 squared, I'm just plugging that in, plus C1 equals 350. All right, let's see. 2 squared is 4. 4 times 16. 4 times 16. Boop, 64. And I'm going to add 64 to 350. And there it is. That's my answer. 350 plus 64. 414. And there it is. C1 equals 414. Oh, she missed it by 2 feet. What do you guys think? Give this question to winners. See if he can solve it with kinematics. You can with a hack. You're going to have to do a hack. Why is this question so hard? Because it doesn't tell you at what time. It just tells you at some instant. So I would assume, I don't know. Okay, high school physics teachers can probably figure it out, right? Of course they can. They know how to do physics. Okay, it gets easy after that. That's probably the hardest question in here. I don't know why that question was not number 10, guys. Okay. A particle is moving along the parabola x squared equals 4 times y plus 3. As the particle passes through the point 6,6, the rate of change of its y coordinate is 4 units per second. So underline that. That is the dy dt. That is 4 units per second. I'm going to leave it like that. How fast in units per second is the x coordinate changing at this instant? They're making it nice. So just do this, guys. Just go x squared equals, and if you want, maybe make life easier, 4y plus 12. You don't have to do that, but I think it makes life easier. Let's see. I have everything I need. Yeah, I got everything. Just take a derivative with respect to time. So 2x dx dt equals 4 dy dt. And look, just plug in dy dt, plug in x, and then solve for dx dt. So 2 times 6 dx dt equals 4 times 4. I'm solving for dx dt because that's what they wanted. How fast in units per second is the x coordinate changing? That's dx dt, guys. Question mark. I know, we're almost done. 12 dx dt equals 16. So divide. So you're going to have dx dt equals 16 over 12, which reduces. 4 goes into 16 4 times. 4 goes into 12 3 times. So 4/3. Bam. What do you guys think? Not bad, right? Not bad. Let's see. Rubbish. This guy, I've never heard someone call it rubbish, but okay. A heap of rubbish in the shape of a cube is being compacted into a smaller cube. Given that the volume decreases at a rate of 3 cubic meters per minute, okay, that's the volume, so I'm going to write dV/dt. So dV/dt equals -3. Find the rate of change of an edge in meters per minute of the cube when the volume is exactly 125 cubic meters. Okay, the volume is exactly 125. So here's my cube. Well, that's actually a pretty good drawing. It's probably one of my better cube drawings. If the volume is, so x times x times x. So volume is equal to x cubed. So 125 equals x cubed. Cube root x equals 5. Okay, I got everything I need. So check it out. Volume equals x cubed. I'm going to take the derivative with respect to time. So dv dt equals 3x squared dx dt. I got everything I need, guys. dv dt was -3 equals 3 times 5 squared dx dt. That's what I'm solving for. Solve. So -3. Actually, you know what? Make life easier. I'm just going to cancel. Cancel. And then that's 25. So I'm going to have -1 over 25 equals dx dt. And there it is. What do you guys think? Okay. Ooh, this one could be brutal. Okay. Yeah, it's going to be brutal because look at all the square roots. Don't worry. This is probably going to take okay, time out. The reason, I know yesterday you guys were saying, give us some Delta Math on this. Guys, Delta Math does not have questions this tough. You did all the Delta Math related rates. Those were all of them. There is no more delta math on related rates. You did them all. So delta math does not have these type of questions. These are at another level. These are quote unquote tough. All right. So give me your A game. If you can figure this question out, then you're going to medical school. You're going to law school. You can figure anything out because you're logical. You can figure it all out. You can put all the pieces together if you can figure this one out. A rectangle is inscribed in a circle of radius 3. Oh, dang it. I didn't want an inscribed one. That's fine. Do you know what that means? The rectangle is inside the circle. Okay, from geometry. If the length of the rectangle is decreasing at a rate of 2 inches per second, okay, so that means the circle's not changing, just a rectangle. How fast is the area changing at the instant when the length is 5 inches? Okay, the diagonal of my rectangle is not changing. Yes, okay, here's what I see. Draw a picture. Draw a picture. Here's my circle. Oh, wow. There's my circle. And here's my rectangle. You don't have to do the sound effects. And my radius of that rectangle was 3. 3. So that means, I'm going to go ahead and do it all. That means, what's easier? Yeah, I think this is easier. So if that is 3, then this is 6. That's static, so I can put that in there. I'm going to say, let me see, what do they use? The rectangle described as the length of the rectangle is decreased. Okay, we're going to say this is the length, and this is the width. Oh, man, you're going to have to use a whole bunch of stuff. Okay. How fast is the area of the, okay, area. Area of that rectangle is length times width. Before you start taking a derivative, you're going to need dl dt, and they do tell us that, I think. The length of the rectangle is decreased. Yeah. dl dt is equal to negative 2 inches per second. Decreasing, because it says decreasing. And Oyani, that's a demerit. All right. Next one. Let's see. What else do we need? Okay. So when we take a derivative, I'm going to need a dl dt, I'm going to need a dw dt, and I'm going to need a w. They tell me how fast is the area changing at the instant when the length is... Okay. The length is 5. So let's figure out what our w is first. So I'm going to go... Look, Pythagorean theorem, guys. 5 squared plus w squared equals 6 squared. W equals the square root, because I get w by itself. 6 squared is 36. 5 squared is 25. Does everyone see where I got that? Gonzalez, you saw where I got it? Yeah, Pythagorean theorem, right? So w equals 36 minus 25, 25, 35, 36. Square root of 11. That's w. I still need dw dt. Chop, how are you going to get dw dt? Like this. L squared plus w squared equals 6 squared. 2L, the L dt, I'm taking the derivative with respect to time, plus 2W, dw dt equals 0. Do you guys see what I did? I'm going to move, let's see, what am I going to move? This guy. Bam. So 2W dw dt equals negative 2L dl dt. Oh, look at that. I can already kind of see the answer. It's going to have to be positive, it looks like, right? Because this is, yeah, we'll just let the math do the work. Divide by 2W. Divide by 2W. 2's cancel out. So dw dt equals, let's see what it equals. Negative times 5, that's what L was, times negative 2, so it's going to turn to a positive, divided by the square root of 11. So 10 over square root of 11 is dw dt. I got everything I need. I just plugged in from what they showed me, right? I'm going to leave the square root of 11 in the bottom because maybe it's easier that way. I don't know. This is the first time I've done these questions, guys. I haven't done it in a while. All right, so here we go. See, this is why these questions are so fun. Imagine being at the university doing these questions. So much fun. dA dt equals first, L, times root of the second, dw dt, have I lost anyone? Plus second, w times the root of the first, dl dt. I'm trying not to touch the picture there. All right, let's see what I get. L was 5. dw dt was 10 over square root of 11. Plus w was square root of 11. And then dl dt was -2. So let's see. 5 times 10. 50 square root of 11 minus 2 square root of 11. Okay, common denominator. So we're done. The answer is in there. And it has to be the positive one. Okay, well, we'll see. We'll see if it comes out negative. The answer is in there, guys. You're done with calculus. You're just doing algebra. I'm going to get, what am I going to get? I'm going to get a common denominator. Multiply the right one here by square root of 11 over square root of 11. So here's what you're going to get. The left is still 50 square root of 11. So this is why I can write it, because this is not a linkage error. This is what that is, right? 2 times 11 is 22. So 22 over square root of 11. Yes. 50 minus 22. Here's my final answer. 50, 40, 30, 28. 28 over square root of 11. Common denominator. So rationalize it, sorry. So multiply by square root of 11 over square root of 11. 28 square root of 11 over 11. And there it is. Square inches per second. Yeah, that one was tough. It had a lot of moving parts, guys. It had a lot of moving parts. We probably spent like 3 or 4 minutes on that. It gets back to easy. A spherical snowball is melting in such a manner that its radius is changing at a constant rate, decreasing from 34 centimeters to 11 centimeters in 30 minutes. That's your DRDT. So let's see. 34 minus 11. 34, 24, 23. So 23 centimeters in 30 minutes. And negative, right? Decreasing from 34 to 20. Okay, so DRDT equals negative 23 over 30 centimeters per minute. Okay. At what rate in cubic centimeters per minute is the volume of the snowball changing at the instant when the radius is 5? Okay, perfect. Volume of a sphere is 4/3 pi r cubed. dV dt is equal to 4 pi r squared dr dt. I'm just going to plug in. dr dt is this guy, and r is this guy. 4 pi times 5 squared times negative 23 over 30. And I'm just going to put it in the calculator. 25 times 4 is 100. Oh, never mind. It's easy to do. Negative 230 pi over 3. And that one. Does this person get it correct? Yep. It was only easy because of the 100. You can move zeros around. If not, just put it in the calculator. Are we doing okay, guys? Or do you guys want me to stop? Or do you guys want me to continue and do the last two? Do the last two? Okay. All right. A 52-foot ladder is leaning against a vertical wall. All right. The wall has to be perpendicular to the ground, right? I guess if you're an architect, you can make different walls. So this is 52, so you can put that in there because that's static. If the bottom of the ladder is, so I'm going to say this is X and this is Y. If the bottom of the ladder is being pulled away from the wall at a rate of 3 feet per second, so that's dx dt. At what rate is the area of the triangle formed by the wall, the ground, and the ladder changing in square feet per second at the instant when the bottom of the ladder is 20 feet from the wall? So X is 20. First thing you got to do is figure out what Y is. So Pythagorean theorem. So we're going to go 20 squared plus Y squared equals 52 squared. Do we need Y? Yeah, let's do it. We already did it. So let's see. Y equals the square root of 52 squared minus 20 squared. Let's see if that's a pretty number. Is it a pretty number, guys? Well, all numbers are pretty, I guess. 52 squared minus 20 squared. 48. Yay. Okay. Whew. All right. So now we know Y. What do we have to do? We need to know dy dt. We have dx dt, but we don't know dy dt. So how are we going to get it? Like this. X squared plus Y squared equals 52 squared. 2x dx dt plus 2y dy dt equals 0. And I'm going to move this to the right. So I'll write it over here. So 2y dy dt equals negative 2x dx dt. Divide by 2y, divide by 2y. So dy dt equals, oh my God. Negative x dx dt over y. Let's see what that is, guys. Dy dt equals negative, what was my x again? Come on, guys, help me out. 20. And then dx dt, what was dx dt? Yeah, guys, are you guys here or not? And then divided by my y value, which was 48. So let's see. 60 over 48, negative. 60 over 48. Math, fraction, enter. Negative 5/4. Okay, now we have everything. So here we go. I'm going to do it in purple, guys. Area is equal to 1/2 x times y. Yeah, let me know. Are we okay? Okay. dA dt. I'm going to group the half with the x first times the derivative of the second plus the second derivative of the first. See? And that's it. We just plug in. So 1/2 times, what was x? 20. And then dy dt was negative 5/4 plus y, which was 48, times 1/2 times dx dt, which is 3. Plug it in. So half of 20, so 10. So 10 times negative 5/4 plus, and then 48 times 3/2. 48 times 3/2. Math, fraction, enter. 119 over 2. Oh, this person got it right. Good job. Whew. All right. This is the last one, guys. Last one. A man standing 13 feet from the base of a lamppost casts a shadow 5 feet long. All right, guys, focus. If the man is 6 feet tall and walks away from the lamppost at a speed of 450 feet per minute, at what rate in feet per minute will the length of his shadow be changing? I love it. Draw a picture. Here's the lamppost. I see a triangle. Here's the guy. This is the shadow in green. I'm going to use S for shadow. And then I'm going to say the distance from the lamppost to the dude. I'm going to say that's X. And this is L for lamppost. Here's the light up there. Okay. I see similar triangles from geometry. Do you see the similar? I sound like Dora. I'm sorry, guys. I wasn't trying to sound like Dora the Explorer. But do you see the similar triangles right there? Yeah. Look at that big one and look at that little one. So here it is. I need to figure out the length of the lamppost, guys. So those are the only two that are concrete. So I'm gonna say, well, let's figure out the numbers first. X was, I think he was 13 feet from the lamppost. A man standing 13 feet from the base. So X is 13. And the shadow S is 5. If the man is 6 feet tall, walks away from the lamppost. Okay, so that's dx dt. Dx dt is 450. At what rate Well, the length of a shadow, that's ds dt. So they want ds dt, question mark. Okay, I need the length of the lamppost. I know it doesn't look important, guys, but it is. So I'm going to say this. I'm going to say 6 is to 5. I'm using the triangle in purple. As L is to 13 plus 5. So let's see what that is. 6 is to 5 as L, 13, 14, 15, 16, 17, 18. 18. So 18 times 6 divided by 5. So let's see. 18 times 6 divided by 5. I'm going to leave it as a decimal, 21.6. Okay. L equals 21.6. Does everyone know how I did that? I just cross multiplied. Okay. So here we go. Now here comes the important part. I'm going to be doing the same thing. So I'm going to go 6 is to S, because that's what's moving, as 21.6 is to X plus S. That's an S, not a 5. So I'm just going to cross multiply. 21.6S equals 6X plus 6S. I just cross multiplied, guys. And I'm going to move the 6S to the left. So 21.6, I'm going to move this guy to the left. 21.6S minus 6S equals 6X. So 21.6 minus 6. What's that? 21.6 minus 6, 15.6? Yeah, maybe we didn't need a calculator for that. 15.6S equals 6X. Here it is. That's it. We're done. We're just going to take a derivative with respect to S, guys, because we know, I already said we're going to take a derivative. So let's take a derivative with respect to T, not respect to S, respect to T. 15.6 ds dt equals 6 dx dt. So ds dt is equal to 6 dx dt divided by 15.6. And I know what dx dt is. So ds dt equals 6 times dx dt was 450 divided by 15.6. So let me take my calculator. 6 times, I already forgot. 6 times 450. 6 times 450. Enter, divided by 15.6. 15.6. Enter. Fraction. Math, fraction, enter. Is that number in there? I really hope, because I don't want to look for an error. 2250 over 13. Is it in there? 2250 over 13. Yes. Hallelujah. All right. Did this help going over this quiz, guys? Be honest. Did it help? For sure. All right, guys. There it is. Have at it. And we're done. You have 50 minutes.